Hi guys! Today we're going to talk about how to determine whether or not a relationship is a function. So today's our introduction to functions. I'd like you to watch the video. I'm going to fill out page 1 of the video study guide. Then please scroll to page 2 and try those practice problems. Finally, go to page 3 and check your answers over with the answer key. Before we start filling out the notes, I just want to front load you with a little bit of information about functions. Take a look at these 3 students. Student number 1 has first period math. Student number 2 has first period ELA. And student number 3 also has first period ELA, so they're in class together. This diagram would be considered a function because each student is only going to one room. So what would it look like to not be a function? This is an example of a relationship that is not a function. So student number 1 looks like they're going to block 1 math, but student number 2 does not look happy. Let's zoom in and look at that face. Oh yeah, pretty upset. Why? Because their schedule says they need to go to block 1 ELA and block 1 science. This is not a function because this student is asked to go to 2 different places. In this story, the students are representing X values and the classes are representing Y values. You'll have a function if every X value goes to just one Y value. And here, a relationship is not a function when an X value goes to multiple Y values, kind of like how this student was scheduled to go to 2 different rooms. All right, now we're ready to tackle these notes. How can you determine whether or not a relationship is a function? Well, every input has only one output, kind of like how every student in the function had only one class to go to. Every X goes to only one Y, kind of like how every student goes to only one class. When you input something into a function, only one answer should come out. Now we can go over some examples of relationships that are functions and relationships that are not functions. Starting with the diagram on the left. Reading this diagram, we find that Abby is 6 years old, Bella is 8 years old, and Christine is 8 years old. This is a function because every input only goes to one output. Every name only goes to one age. And it's okay that Bella and Christine are both 8 years old. 2 girls can have the same age. That will happen in life. It's still a function. This next example says Eric is 10, Fred is 9, Fred is 12, and Greg is 11. Did you catch what was weird about Fred? When I input Fred, I got 2 different ages. This is not a function. When you input Fred, you find out that he's both 9 years old and 12 years old. But every input should only go to one output. Every name should only go to one age. Our next examples are tables. The input is always the X value and the output is always the Y value. So this says 3 goes to 1, 5 goes to 2, 7 goes to 3, 9 goes to 2, and 11 goes to 1. This is a function because when you input each number, it only goes to one output. Now you might have noticed that some inputs share an output. For example, 3 goes to 1 and 11 goes to 1. That's okay, it's still a function, kind of like how 2 students can go to the same class. In this next example, 1 goes to -9, 2 goes to -8, 3 goes to -7, 4 goes to -6, 4 goes to -5. Take a look at those 4s. This is not a function because the input 4 is asked to go to 2 different outputs. It's kind of like asking a student to go to 2 different classes at the same time. Moving on to the ordered pairs. 2 goes to 5, 4 goes to -2, 3 goes to 3, 5 goes to 4, and -2 goes to 5. This is a function because when you input each number, it only goes to one output. Now, it's okay that some inputs have the same output, like 2 goes to 5 and -2 goes to 5. It's all right if they have the same output. It's kind of like how two different students can go to the same class. This next ordered pair says 6 goes to -1, -4 goes to 2, 5 goes to 2, 4 goes to 6, and 6 goes to 5. If you look carefully, this is not a function because in the first ordered pair, 6 goes to -1. In the second ordered pair, 6 goes to 5. But every input should only have one output. The last thing we have to talk about is how to check whether a graph is a function. And there's an easy way of doing this called the vertical line test. In this test, no matter where a vertical line is placed on the graph, it can only go through the relationship at most once. So here's a vertical line. You're going to notice that no matter where the vertical line falls on the coordinate plane, it only intersects with my relationship at most once. That means that this is a function, and our reasoning is it passes the vertical line test. So let's take a look at the next example. I'm going to make a vertical line. No matter where I drag this vertical line on the coordinate plane, I again notice that it only intersects with my relationship at most once. So I'm leaving the vertical line here just as an example. That means that this is also a function. So both of these graphs are examples of functions because they pass the vertical line test. For my next example, I'm dragging a vertical line across the coordinate plane, and I can pretty much stop right here because this vertical line intersects the circle at 2 different points, which is more than once. So we say this is not a function because it fails the vertical line test. And for my last example, I am dragging a vertical line across the coordinate plane to see if it ever intersects more than once. And right here, I notice that it intersects at 2 different points, which means that the x value, 2, has 2 different outputs, a y value of 2 and the y value of -1. So it fails the vertical line test. And with that, we are now experts. So please try those practice problems and check your answers with the answer key. You can always come back to these modeled examples if you have any questions. And the last page of this document is the story of those students going to different classrooms, if that helps jog your memory too.